Hi, fifth grade. In quarter one, our math work sample focused on exponents, algebraic thinking, and using grouping symbols. I'm going to go over a couple of problems from that work sample. Follow along with me, work through these problems together, and you will have the opportunity to increase your score if you would like for that work sample. Let's start by looking at using algebraic thinking to create an expression that matches both the written piece and a numeric point of view. So starting with number 4 here, we see the expression, and I'm going to read this 4 times, and then in parentheses, we have 8 plus 12. So if we were to translate this into a written sentence, we're going to use some of the words that match the symbols that we see. When you see a multiplication symbol, anytime you're talking about multiplication, the answer is going to be called the product. When we are adding something, the answer is called a sum. So since the sum of 8 and 12 are in parentheses, we're going to need to keep those numbers together in our written sentence. And then 4 times, we might say the product of that. So we could say, based on these choices, we see 4 times 8 and 12, 4 times the sum of 8 and 12, or the quotient of 4 and the sum of 8 and 12. Well, the first choice here, 4 times 8 and 12, kind of sounds like we're multiplying because we see times, but we're not entirely sure which numbers here. Is it 4 times 8 and then 4 times 12? Well, no, that's not what they're asking us to do here. We need to make sure that the sum of 8 and 12 is included in there. The second choice says 4 times the sum of 8 and 12. Well, there we go. We have the sum of 8 and 12. That's important. And it says 4 times. We know that we're multiplying here. That's a good option. Let's check one more to be sure. The quotient of 4 and the sum of 8 and 12. Well, it has the sum of 8 and 12 that we want, but quotient means divide. So I don't have any division going on here. I know that this expression matches 4 times the sum of 8 and 12. Let's look at number 7 here. As I look through my answer choices, I know that I'm looking for something involving subtraction, which the answer to a subtraction problem is called a difference. And I also see division. This bar means divide, just like this symbol here. So dividing, the answer to a division problem is called a quotient. So let's look at our choices. 22 minus the quotient of 18 and 6. We see minus, we see quotient. Let's make sure they're in the right place. The quotient of 18 and 6 would mean 18 divided by 6. 22 minus that quotient. Okay, this is looking good. Let's check our other choices to be sure. 22 minus the product of 18 and 6. Okay, this one's very similar, but it says product. Remember, product means times, quotient means divide, and we want quotient. So we can cross this one out here. And our third choice, the quotient of 18 and 6 minus 22. This has quotient and it has minus. However, they're in the wrong order. The quotient of 18 and 6 is right. We're clearly dividing 18 divided by 6. But 22 is the number that should come first because we're subtracting the quotient from 22, not the quotient minus 22. So this one's close, but not in the proper order. Remember, if we use the order of operations, we always do what's in parentheses first, if we have any, and then exponents, which there are none in either of these problems. Then we do multiply and divide together, add and subtract together, and those go in order from left to right, same order that we read and write. So we would be doing the division of 18 divided by 6, subtracting that from 22. We can confirm this is our correct answer. Another type of problem that we saw was doing that process in reverse, taking a situation and writing it as a numeric expression. So Min spends this amount of money. So this amount of money is what we're trying to solve for. He buys a pen for $2 and an ink cartridge that is on sale for $10 off the regular price of $35. Okay, so $10 off that regular price of $35. I recognize that I need parentheses around this because these are working together. The $2 pen was not $10 off. The whole price, putting it all together, the pen plus the ink cartridge was not $10 off. It was just $10 off of the price of the ink cartridge, which was regularly $35. So I'm going to need 35 and 10. Subtracting those, because I'm taking $10 off, I need that to be in parentheses. To figure out how much money Min spent, I'm also going to have to add to that the cost of both the pen and the ink cartridge. So when I look at my choices, I see 35 minus 10 minus 2. Well, 35 minus 10, I agree, is a good start, but minus 2, that's not going to help me figure out how much money he spent altogether. 2 plus 35 minus 10 in parentheses. Yeah, well, this has 35 minus 10 just grouped together. That's correct. I'm adding 2 to get the total cost of both things that he bought. This looks good. Let's check one more. 35 minus 10 plus 2. Well, this has 10 plus 2 in parentheses here. That's not correct. It was $10 off of 35. If they had put the parentheses like this, then that totally could have worked. 35 minus 10 in parentheses, then plus 2, that would be okay. But given our choices, this second option is correct. One more thing that I noticed that many people struggled with on our work sample was our exponents. So exponents here, we're doing powers of 10. An exponent means the little number floating here is an exponent. The big number is our base. What an exponent tells us to do is multiply the base times itself as many times as the exponent says. So when we're figuring out how many bytes are in a gigabyte here, they gave us this info on the chart that a gigabyte is about 10 to the 9th power bytes. So that means 1 times 10 to the 9th power in order to solve that here. 10 to the 9th power as an exponent means I'm multiplying 10 times itself 9 times. So I'm going to write that out up here. So 10 times 10, there's 2 of them, times 10 is 3, times 10 is 4, times 10 is 5, times 10 is 6, times 10 is 7 of them, times 10, there's 8 of them, times 10, 9 times. So 10 times itself, 9 times here. That's what this expression means. To write our answer as a whole number, I can think about, especially when I'm working with powers of 10. This doesn't work for all exponents, but anytime it's a power of 10, this works. I look at the exponent. The exponent is 9. So when I'm working with powers of 10, that tells me that my number needs to have 9 zeros. So I'm going to start with my 1 here and then add 9 zeros. 1, 2, 3, 4, 5, whoops, there we go, 6, 7, 8, 9 zeros. I count back every 3 zeros to put my commas in. A little sloppy, but that's all right. Oops, one more comma. And I know that 1 gigabyte is about 1 billion bytes. 1 billion bytes. I'm going to put my B for bytes here. If you go back, this is 1,000, thousands place. This is a millions place. This is the billions place, so a lot here. if I were to, let's just do one more. If I were to do 10 to the fourth power, this would mean 10 times itself. 10 times 10 times 10 times 10, 4 times, which would be the same as a 1 with 4 zeros. I go back 3 and add my comma. 10 to the fourth power would mean 10,000. So as we have reviewed a couple of things, check out the link to update your score. Sorry, not add to your score, but update your score by completing a couple more problems relating to these three standards. Thanks for watching, guys.